So this is part two of the Monty Hall implementation with Python. Now we're going to get into the nuts and bolts of it. So previously what I did is had to look at a couple of the key set theory operations: union, intersection, and set difference. Okay, that was from the last presentation. So I'm just going to move on from that, and we'll get stuck into the Monty Hall problem. Okay. So this is a sort of command I'm going to use. There's actually other commands, obviously, but what I'm going to do here is go this is my doors here, doors 1, 2, and 3. Okay, and I'm going to use this command np.random. That's just a sort of from the random operations from numpy. I'm going to choose the choice. This is the choice command. Okay, and it's just going to choose one item from doors. Okay. And so we're going to need one for the correct door. So correct equals pick choose one from doors. Okay, and likewise we need a choice door. So the correct door is where the car is. The choice is what the contestant selects. Okay, so let's run that. I have it run there. So the correct door is 3 and 1. Let's just run it again. 3 and 2 this time. So the correct door is still 3, but the contestants chosen 2. Let's run it again. Oops, go back up here. And this time the correct door is door 1, and the contestants correctly chosen door 1. I'm going to use this for a minute. So the current scenario is correct door is choice 1, door 1, and the contestant has chosen door 1. Okay. So Monty has to open a door. He's going to reveal a goat. So we're just picking out a door to reveal a goat. Now he has to choose an incorrect door, and also he can't open the door with the car behind it because that's not a goat. So he has to pick a door with a goat behind it, and he can't pick the right. He can't pick the correct door, and he can't pick the door that the contestant has just chosen. Okay, so he's got these two constraints to live with. Now, so the doors that must stay closed are the correct door and the choice door. Okay, and the can open is whatever's left. It's the complement of that. So first off, the doors that must stay closed, in this case, is door 1. Okay, which is the union. It's the correct door and also the choice door. So the door in this situation, the goats are behind door 2 and 3. So Monty can pick either door 2 or door 3 to open to reveal a goat. Now I'm just going to sort of backtrack a bit here. Let's just change this scenario again. I'm going to just sort of, let's suppose they are different doors. So now I've changed it. The correct door is 2, the choice door is 3. And what does that make of this? That means the doors that must stay closed are doors 2 and 3. And in this situation, Monty can only open one door. So there can either be one door or two doors in the can open group, depending on whether or not a contestant got the answer right the first time. Now, what we're going to do is pick one door from that can open group. Okay, so remember previously we could have two options here, or one option. So this is our reveal goat situation. So in this case, there's only one choice. So he's picking randomly selecting one from a set of 1. So you only have one. So he's going to open door 1 here to reveal a goat. Okay. Now, suppose no, I'll keep going. So 2 doors are still closed. No matter what happened previously, 2 doors are still closed. Okay, so we can sort of reset the clock a bit. We don't have to worry too much about what happened in the past. 2 doors are still closed, and that is the one that was not opened. So we reveal the goat. Okay, and so there's a goat behind one of those doors, and reveal goat was door 1. And let's just print that. Print is just a sort of quite handy for the sake of IPython notebooks if you want 2 outputs from the same cell, and still closed. Stay closed and still closed are different. Okay, So still closed is after is what happens when reveal goat takes place. Now you will often get the same answer, but sometimes if stay closed are doors that must stay closed. Still closed in this scenario is situation is just the doors that happen to be still closed. Doesn't say anything about whether they're right or wrong. Okay, so we're down to doors 2 and 3. Those are the doors that are still closed. So he has the correct choice. So sorry, let's see where we are. Sorry, contestant's choice. Can stick or switch? Stick, no change. Switch, change to other unopened door. Okay, so stick is, or I'm just going to rename the choice door as stick, as what happens when you stick. Okay, and switch is what happens when you switch. So it's the other door from still closed. Is the door you stick with. If your option is to stick, we're going to call it stick, which is your original choice. I just renamed it. Or switch, the door you choose if you switch to the other door. Okay, let's just reprint that because I think those numbers are a bit. There we go. So a bit out of date. So what the door you pick if your stick is 3. The door you would have if you switch is 2. Okay. So what we do is have to find out how things work out. So print stick is correct or switch is correct. Okay. So stick is correct, switch is correct. In this case, stick is not correct. Switch, you would have been right to switch here. Okay. So switch is correct, true. Okay, that was the door. The switch door is the correct door. The stick door is not the correct door. Okay. Now we can integerize this. These are Boolean operators here. Print true and false, but we can integerize them. Okay. Such that the output is 0 or 1. Okay. Now, so print switch equals correct if that's the integer. Integerize that. So that turns the true into a 1. Okay. So what we're going to do now is write a function. Okay. And it returns 1 if stick was a good strategy and returns 0 otherwise. Okay. And so if switch was the right strategy. But I'm just going to sort of concentrate now solely on stick, the stick option. So Monty Hall stick, this is actually all of the commands that I've used previously. I've shortened it down a bit, but so what happens here, it picks out all these doors and it would integerize the outcome. So the outcome is essentially, do I need that? I don't think I need that. So it would just essentially would run the entire simulation and would just print 1 if it happened to be the case that sticking was the best choice. So let's just see how this command works. It's just putting everything into a function. That's all. And there's no inputs or anything like that. And it just runs the experiment and prints out 1 result. There we go. It turns out that sticking was the right option in this case. In this run the experiment that time. Run it again. Run the experiment again, and it turns out sticking was not a good option. Okay. So now what we're going to do is just run this for loop. This is actually just run a for loop here. So I'll run the experiment 10 times and see how many times sticking was the right option and switching was the right option. Here it's only like 2 out of 9 times that it was the correct option. Okay. So and now what we're going to do is count up how many times over the course of how many experiments, so this is out of 9 experiments, how many times it was the correct option. So let's run this. I'm going to change this to 0. This is just a sort of range, so that we have 1,000 numbers 0 to 999. What we're going to do here is have a little counter, and to count how many times sticking was the correct option, and essentially initialize it to 0, and then for every loop in the for loop, okay, we would have the counter would be updated by the output of the successive experiments. So mhstick runs the experiment, just prints out 0 or 1, and we just add that to our count, no problem. And let's just run that such that we have it 10,000 times. Just give it a minute to run. There we go. Out of 10,000 runs, the stick option was only the right option. Sticking with your original choice was only the right option 3,423 times. That is to say 34%. Okay. So that's the Monty Hall experiment using very simple set theory stuff. Again, this is the main command the main function up here. You can actually boil that down into a much nicer, easier to look at command, the function, with much less code. I'm sure of that. But the thing is, it just once you get the hang of the problem, you can do that. But the first step you have to do is get the hang of the problem. Okay, so it's, in the meantime, before you have the hang of the problem, breaking it up to very small chunks is the best strategy. Okay, so that is Monty Hall implemented with Python, part 2, done and dusted. Goodbye.